So this is another example about how to find a maximum or minimum using a y-prime number line test. And you'll remember from the other example that if you know anything about the derivative, you know that when the derivative is positive, the function's going up, and when a derivative is negative, the function's going down. So if I had a function where the derivative was positive and then the derivative suddenly switched to being negative, I know that right here there must be a max or a min. And in this case, this would be a max, changing from a derivative of positive, which is going uphill, to a negative derivative, which is going downhill. So that's what I'm looking for with this max or min number line test. So let's say I had another function. This time this will have a max or min because I'm going to pick one that is a polynomial. And I can see that this function is cubic, which means it has two bins. This function is a polynomial, like I said, so the derivative is always going to be defined, and I already know certain things about this, even though you don't need to know any of those to find the derivative, which would be 3x squared plus 6x plus 3. Okay, so finding the derivative, then what I'm going to do for my critical numbers is when is my derivative undefined, when is my derivative 0, and where are my endpoints. So for my critical numbers, the derivative is 0. I'll set this equal to 0. There are two ways to do this. Well, more than that, but the two ways to do it by hand are to factor this. And then also I could use a quadratic formula on this. So right here, what multiplies to 1 and adds to 2, that would be a 1 and a 1. And so when is this derivative equal to 0? That's at x equals negative 1 and x equals negative 1 again, so really I only have to count that once. Okay, so that's where the derivative is 0. Going back to my derivative, where is this derivative undefined? Well, this derivative is a polynomial also, so that's never undefined. So this is my only critical number. And so I'll make a number line. And this number line is going to be for a derivative. I'm going to put my critical numbers on there, which in this case I only have one of them at negative 1. And I'm going to pick some numbers on each side of negative 1. So this time I'll make sure the 0 is over here, which is not. 0's over here, and we'll put maybe negative 10 or something like that. So make sure these numbers are in order when you're making your number line. What you want to do is check the sign of the derivative. You don't really care necessarily about what these numbers are, you just want to know the sign. So you can plug in a 0 into here, or you could use this one, or you could use this one. And so I'm going to put it in right here because I'm only looking for the sign. And I can say this is positive times a positive times a positive, which is going to be a positive. And if I put in a negative 10, this is going to be a positive times a negative, which is another positive. And so what this tells me is that my derivative is positive, then my derivative is 0, then my derivative is positive again, which is a function that looks like this. Increases and then has a horizontal tangent and then increases again. And so this particular polynomial doesn't have any maxes or mins because this, where the derivative is 0, is not higher than everywhere else and it's not lower than everywhere else. So that's what I said in the last video about sometimes you'll have a critical number that does not pan out to be a max or a min. So that's why you have to go ahead and check all these critical numbers on a number line and verify that this number line changes signs around your critical number. What you're looking for is a number line that looks like this. You might make a number line and you might have some critical numbers like negative 3 and 2. And you'd pick some numbers in between there like negative 4 and 0 and 3. And maybe this would look like this. And so this would tell me that if the slope is positive, then the slope is negative, then the slope is positive again, that I must have a max at negative 3, and I must have a min at x equals 2. And just like in the first video, if you wanted to find the entire ordered pair where this max occurs, it would be negative 3 comma something, you would plug this back into the y of the original. Like right here, if I wanted to know the rest of this ordered pair for some reason, I would put a -1 back up here into the top, where it says, this literally says the y is, this would be -1 cubed plus 2 times -1 squared plus 3 times -1 plus 2. So that would be a 0, -1, 0. And that would be the whole ordered pair where this transition occurred. And you could do the same thing down here to find these entire ordered pairs where particularly this max occurs or this min occurs. So that's how you find a max and min with a y prime number line test.